In this video, we'll look at downloading and uploading code to GitHub in a repository that we own, not using this drag and drop method on the website, but using GitHub pull and push. Now let's install GitHub desktop software first. So this isn't totally necessary, but I'm hoping it's a nice easy way to interact with GitHub. Here, download for, I'm on an Apple Silicon Mac, so I'll click this button and do the usual next. Okay, drag and drop this into the applications folder, and I can get rid of the zip. Yes. Okay, now it's asking me to sign into GitHub, which is perfectly reasonable. I'm already signed in, so it should be pretty straightforward. It wants to be able to read all my public and private repositories. That's exactly what we want. Authorize it. Okay, now once you set up Git on your local computer for the first time, it does want to know which email address and which is the username for the person that will be creating new code. Now, if you just wanted to just copy the GitHub ones, that's perfectly fine, or you can change it up. I just match it to the GitHub one. That actually makes some other things a bit neater on GitHub. Okay, agree to that. Okay, now it's noticed that I have a repository, so if I look at my own profile, I've just got one repository here, a test one, and that's showing here. Let's click on that and let's clone it. So that's saying, give me a local copy of this repository that's also stored on GitHub. So if I clone it, where does it want to go? Okay, sure, let's let it go there. Okay, now this is a bit obscure. Let's maybe look in the file system to see what happened there. So it said it would go to the documents folder, GitHub, and then make a new folder for that repository, testing GitHub. Now I've got a copy of all those files that are in this repository. Let's say hello.py, have a look on the website. If we have a look on our local computer, it's the same. Okay, so let's maybe open up that folder in VS Code. So home, documents, GitHub, testing GitHub. Okay, so here, if I want to start making changes, let's say this code is also on my local machine. So I add a new line here. Now if I go back to GitHub desktop, I can start seeing something interesting. It is showing me the parts that I have changed locally. And we can see here, we've got plus this green line is saying everything else in the repository has not changed. So we haven't changed this readme file, we haven't changed that other notebook thing. It's just the hello.py file, and inside the file everything has stayed the same except we've added one new line. Now if we make some other small changes, so let's see, make that lowercase and save, then we can see again, okay, we changed that line. It shows us like deleting the whole line and rewriting it, but you get the idea. We're seeing only what changed. Now we can create a commit. So this is a bundle of changes, and which we give it a meaningful name. So we say added some new print statements. And if I commit the file to main, let's see what happens. Now, if I have a look back on the website, look at the repository, I can actually see that hello.py on GitHub hasn't changed. So this is actually kind of an interesting design that Git uses. So it allows our version of the code to sort of progress a bit on our computer, on our hard drive, called the local machine, and we can get ahead of the version that's stored and backed up on the website github.com. And we can see here as well, I have one local commit waiting to be pushed to GitHub. So if I push that button, it'll start updating the website version as well. But I don't need to press that straight away. Maybe I can add some more changes. Yeah. Add another line of code here. Go back in, see the new line of code. Print message inside is prime. I can commit that as well. Now I've got two commits that are ahead of the remote branch, the copy that's backed up to github.com. If I look at the history here, I can see all the things that have changed in the past, and I can see these last two have not been backed up to github.com. So maybe what I would do, for example, if I'm coding away on some project all day, probably commit during the day, and then when it comes to the end of the day, if I'm pretty confident with all that code that I wrote, push it to GitHub as a backup. I don't normally just go commit, push, but you could if you want to. So now that I've got these two new commits, I'll hit push origin, see how that goes. Okay, if I go back to the website, refresh the web page, we can see the code has changed. We've got the new commit message from that last commit, and the two new commits are actually shown there. So it updated both of them at the same time. Just to really prove it. Yep, that's the latest change. Now if we do this in reverse, it's called pulling. So let's say with GitHub, you're often working with other people in the same repository. It's not just you alone. I mean, it's designed for collaboration, even though a lot of the times as a researcher, you might be the only one committing to a repository. But let's say someone else did change, or you make a change, but on the website directly, that has the same effect. Someone else makes a change, and I'll do that I'll simulate that here by just changing the README on the website version. So I've added some text to the README file. Commit that. That's a fine commit message. Now if I go back to the repository here, we can actually see that the README has been updated. But if I go to my copy locally, have a look at the README, it's still the same. So this is the opposite scenario to what we had a moment ago. Is that even correct English? The opposite scenario to the one that we had a moment ago. Now, before we had new code that was on our computer but wasn't on GitHub. Now we've got it the other way around. We've got new code on github.com that's not on our computer. Now what we want to do is pull that code down to our computer. And I have no idea how to do this with the software. I've never used it. So let's see if I press this fetch button, what happens. Okay, good deal. So fetch is the GitHub kind of terminology for just having a look at the GitHub repo and saying, okay, did you do anything different? Is there something changed that I don't know about? Once I've done the fetch, it now knows that github.com has some new code, new changes in that form of that commit that are not on my local computer. So if I want to get them locally, I click on the pull. I have to pull that down. And then voila, we can see in the background there the readme.md actually updated in real time. It changed that file so that now we have that commit, the new readme.md file. and we're in sync between our computer, which we could look at this code even if we turned off the internet. We're in sync right now, at least, between this copy and the copy that's on github.com. Okay, so that's it for this video. I hope it simplified a little bit what's going on with the Git and GitHub. To be honest, it's the whole Git thing is designed a few decades ago. The user interface is, in general, awful, and there's not much that can be done about that. So this GitHub desktop is kind of making it a bit nicer than the default way. The default way is to go into the terminal and start writing git add, git pull, all these commands manually, which is what a software developer would have memorized over years of misery and mistakes. But since I'm assuming if you're using this for data science, you'll have a relatively simple use case compared to what a traditional software engineer would need this for. I'm hoping it's a kind of smooth pathway for you. Just slowly add commits, bundle the changes into a commit, push them to GitHub as a backup, make sure that they're publicly available once you're ready for that. Okay, that's all for this video.